All right, let's dive into some fascinating and, frankly, kind of weird new data from NASA. We're talking about a visitor from a whole other star system, an object they've named 3I/Atlas. And get this, a new alert just came out saying it's not behaving like anything we've ever seen before.
And that's really the heart of the mystery here. I mean, what happens when something from out there just shows up and decides our laws of physics don't apply to it? We have all these models that are supposed to predict how things like comets work, but this thing, it seems to be playing a completely different game. And we're just now figuring out how much that changes things.
So here's the core of the problem. This comet, 3I/Atlas, has already swung past our sun. It's on its way out, heading back to the freezing cold of deep space. By all accounts, the show should be over, but it's not. In fact, it almost seems like it's just getting started.
And look, we're not talking about a small little error in the calculations here. Every single simulation, every computer model, every bit of history we have says this object should be fading away, turning back into a quiet, dark piece of rock. Instead, it seems to be waking up, getting more active the further away it gets from the sun. How is that possible? Okay, to really get your head around how bizarre this is, we need a quick refresher on the standard playbook for a comet. You gotta know the rules to appreciate just how spectacularly 3I/Atlas is breaking them. So on the left, you've got the normal, predictable story. A comet gets near the sun, it gets cooked, puts on a big, beautiful show with the tail and all that, and then as it flies away, it goes quiet. Simple, right? But then you look at 3I/Atlas on the right. It's not cooling down. It's still pumping out gas. Its tail and that glowing halo around it, the coma, are being fed fresh material. It's acting like it's still right next to the sun, even though it's moving farther away every second. So, how do we know all this? Well, this isn't just a hunch. This is all based on cold, hard data and images that are coming in from our telescopes right now. Let's walk through the evidence that has so many scientists scratching their heads. The first and maybe most obvious clue is its light curve. That's basically just a graph of how bright it is over time. Normally, for a comet heading away from the sun, that graph should be a steep nosedive into darkness. But for 3I Atlas, it's a flat line. It's just refusing to get dimmer. And when we look at the actual high-res photos, the proof is right there. Astronomers can see a brand new shell of gas forming around its core, almost like a fresh ring on a tree. That means it just had a huge burst of activity. Not only that, but its tail has this sharp, bright spine running down the middle, a dead giveaway that there's a jet of gas continuously firing from its core. There's a quote floating around the research community that I think just sums it all up perfectly. It's one thing to be a little off from the models. It's something else entirely to act in the complete opposite way of everything we predict. But hang on, because here's where it goes from weird to truly bizarre. It's not just glowing when it shouldn't. The data is showing that it's actively pushing itself around, changing its own flight path through the solar system long after its engines should have sputtered out. This happens because of something called non-gravitational forces. You can basically think of them as little rocket thrusters. When a comet shoots out a jet of gas, that jet pushes the comet in the opposite direction, right? It's the rocket effect. For 3I/Atlas, those little thrusters should be fading out, but they just aren't. And this chart really shows you what's going on. Gravity is still the main driver, of course, but look at that rocket effect. See that tiny little bar for what we expected it to be? Now look at the much bigger bar showing what's actually happening. Those jets are still firing with enough force to steer this thing in a way that gravity alone just can't explain. So we have an object that's too bright. It's firing jets. It's steering itself. What in the world is going on? Well, the leading theory paints a pretty violent picture of a chaotic process happening deep down inside the comet's core. Here's how it's supposed to work. When the comet got close to the sun, the surface got absolutely roasted. But heat takes a long time to travel through something like a comet, so now, even though the surface is cooling off, a heat wave is still making its way down into the frozen center. And when that heat finally reaches these deep pockets of ice that have been frozen for billions of years, they don't just melt. They detonate. They flash instantly into gas and explode outwards. So every one of those new shells of gas we see, that's another deep pocket blowing its top. The whole process basically turns this comet from a quiet frozen rock into a totally volatile cosmic pressure cooker, with these incredible forces building up deep inside. And that pressure cooker is unbelievably dangerous. Those jets aren't just firing in a straight line, they're firing off randomly, creating torque, making the comet spin and twist.
We've seen this happen before with our own comets. They spin up too fast, the stress becomes too much, and they literally tear themselves apart. And some astronomers have noted that 3I/Atlas has this weird elongated peanut shape, which might be the first sign its structure is starting to fail. Which brings us to the final act of this whole drama, an act that hasn't been written yet. What we're watching in real time is a high-stakes structural integrity test on an object from another star, and nobody knows if it's going to pass.
That's the first huge question. Will all this activity finally die down, and will it survive its trip back out into the void? If it does, what a story. The incredibly tough interstellar traveler that stared down our sun and lived to tell the tale.
But what if it doesn't stop? What if those jets keep firing and the spin keeps getting faster and faster? We could be watching the final moments of 3I/Atlas, right before it shatters into a string of little fragments, a ghost of what it used to be. And this brings us to the most provocative question of all. Why does this chaotic process seem so weirdly controlled? The steady push, the regular pulses of gas. It feels less like a series of random explosions and more like something that's actively fighting to stay awake, almost like a spacecraft firing its thrusters for a course correction.
So what will the next update tell us? Will it finally be asleep? Will it be in pieces? Or will it be something else entirely? We don't have the ending to this story yet. All we know is that there's a visitor from another star up there, and it's refusing to follow our rules. We're watching a ticking clock, and with every new piece of data that comes in, that ticking is getting